Hello students, welcome to Abdemi. In today's online class, I'll be talking about a problem on refraction of light. See the problem, what is the statement of the problem? Carefully note. The XY plane is the boundary between two transparent media. Medium 1 with Z greater than equal to 0 has a refractive index √2 and a medium 2 with Z less than 0, less than equal to 0 has a refractive index √3. A ray of light in medium 1 given by this vector A 6√3i plus 8√3j minus 10k is incident on the plane of separation. Find the unit vector in the direction of refracted ray in media 2. So, a ray of light is represented by a vector. Incident ray is given, incident ray vector. Refractive indexes they are provided. Then, what is the vector along the refracted ray that is to be determined? What is the unit vector along the refracted ray that is to be found out? Okay. Now see, just let us try to draw a representative diagram for this problem. So, this is XYZ coordinate axis. So, let it be x-axis, this is y-axis and this is z-axis. Okay, so this is xy plane which is perpendicular to the plane of the board. We are assuming yz plane is the plane of the board, xy plane is perpendicular to the plane of the board. So, just let us try to represent xy plane. So, this is negative x-axis you can say, and this is negative y-axis you can say. Okay, so this plane is xy plane. Now you see the vector, incident ray vector is actually 6√3 I cap plus 8√3 j cap minus 10 k cap. That means it is the position vector of the point 6√3 8√3 minus 10. So it is directed, probably the ray can be written like this, drawn like this. This is the incident ray. It is hitting the xy plane at this point. Okay, so this is xy plane. And this is hitting xy plane at this point. And see the medium 1, this is medium 1 having refractive index n1 equal to √2. And this is just below the xy plane, the medium is medium 2 having refractive index n2 equal to √3. So you can assume safely that medium 2 is denser medium. So the refraction is from rarer medium to denser medium because second media 2 has higher refractive index. Now this is the normal at the point of incidence. So here the normal is in this direction and here the normal is in this direction. Okay, and normal is normal to xy plane, therefore normal is parallel to z axis. So I can write the normal vector on xy plane for the incident ray. I can write it as k cap. Okay, So this is k cap vector, and this is the normal vector. Here it is normal to the surface. For the refracted ray, I can write it minus k cap vector, just opposite to positive z direction. And the refracted ray will move like this. So this is incident ray, this is refracted ray. So let this be the angle of incidence, theta 1, and let theta 2 be the angle of refraction. Theta 2 is the angle of refraction in media 2. So simply once again, if I draw, this is k cap vector, normal vector, this is incident ray, theta 1 is the angle of incidence, and after refraction, this is minus k cap vector, this normal is opposite to k cap vector, and this is the angle of refraction. I call this theta 2. Alright, and this vector is a vector, and this vector, if I call refracted ray as b vector. Okay, and this plane is actually this plane, this surface is the xy plane. Okay, so this is the xy plane. So on xy plane, the ray has incident. Just let me use different color. So it is like this. This is the angle of incidence. This is the angle of refraction. This is theta 1. This is theta 2. I hope the drawing is clear. Okay. Now, if A is the incident ray, then unit vector along A, which I call A cap, is actually, before that, let me calculate the mod of A. So mod of A is how much? Mod of A is square root of 36 into 3 plus 64 into 3 plus 100. So it is how much? Square root of 108 plus 192 plus 100, which is equal to 400. Square root of 400, that means 20. So unit vector along A cap is actually 6 root 3 by 20 I cap plus 8 root 3 by 20 j cap minus 10 by 20 k cap. As simple as that. Now, if this is the incident ray A vector, now let me calculate minus A cap dot k cap. This thing, minus A cap is in this direction. So minus A cap dot k cap. So it is, I can write it in two ways. It is simply half k cap dot product A cap minus A cap dot k cap is actually half. Another way I can also write minus A cap. You know from your vector knowledge is nothing but mod minus A cap into mod k cap into cos of the angle between minus A cap and k cap, which is nothing but the angle of incidence, cos of theta 1. But these two are one, unity. This is unity, this is also unity. So it is cos theta 1. So cos theta 1, if we equate these two, is nothing but half. So it is A dot k cap is actually, it is not written, it is half. A dot k cap is A dot k cap, A cap dot k cap is equal to minus A cap dot k cap is equal to half. Okay. Okay, so it is half k cap dot k cap. You can say it is half. So cos theta 1 equal to half implies theta 1 is 60 degree. Okay, so theta 1, this angle is 60 degree. Now we know Snell's law, which is n1 sin theta 1 is equal to n2 sin theta 2. So n1 is how much? n1 is root 2. Therefore, root 2 sin 60 degree is equal to root 3 sin theta 2. Therefore, sin theta 2 is root 2 by root 3 sin 60, that is root 3 by 2. So it is 1 by root 2. So sin theta 2 is 1 by root 2. Therefore, theta 2 is 45 degree. So this angle is 45 degree. So this angle is 60 degree, theta 1, whereas this angle is 45 degree. Alright. So we have arrived up to this point. So what we did, A vector is given, we computed A cap vector and found minus A cap dot, because minus A cap is this vector in this direction, unit vector along this direction from point of incidence to this direction. So minus A cap dot k is half. On the other hand, minus A cap dot k, we can write it is magnitude of minus A cap into magnitude of k cap into cos of theta 1. Therefore, it is cos theta 1. So cos theta 1 is half, from which we found theta 1 is 60 degree. Now applying Snell's law, n1 sin theta 1 is equal to n2 sin theta 2, and therefore from that we found theta 2 is equal to 45 degree. So we have applied Snell's law and found theta 2 equal to 45 degree. Now we have to find out the vector, unit vector along the refracted ray. So this vector, if I call unit vector along refracted ray, if I call it b cap. So b cap, let me write. So these are not required, we can remove this. So only we need to retain this A cap expression for the time being. Okay, and I can remove this also, this is also not required. Now let the unit vector along refracted ray be b cap. So b cap, let me write, let b cap be alpha I cap plus beta j cap plus gamma k cap, where since b cap is a unit vector, therefore alpha square plus beta square plus gamma square should be equal to 1 square, which is 1. Alright. Now unit vector along the normal below xy plane is minus k cap, that we have already written. So b cap dot minus k cap is how much? Simply it is minus gamma. Also from this b cap dot minus k cap is minus gamma. Also we can write b cap dot minus k cap as magnitude of b cap into magnitude of minus k cap into cosine of the angle between minus k cap and b cap, which is nothing but the angle of refraction. This is theta. Okay, so theta 2 I have already found 45 degree. So it is cos theta 2 only, because these two are unity. Cos theta 2 is cos 45 degree is 1 by root 2. Therefore, since b cap dot minus k cap is minus gamma, and here it is 1 by root 2. So gamma I find, this is one important result. Now alpha square plus beta square plus gamma square equal to unity, that we know, because b cap is a unit vector. Now there is a very important part of Snell's law, is that all the ray, incident ray, refracted ray and the normal on the at the point of incidence, they lie in the same plane. That means I can say a cap is the unit vector along incident ray of incidence, b cap is the unit vector along the refracted ray, and k cap is normal at the point of incidence. They lie on same plane, This is also another very important part of Snell's law. Snell's law does not only say that n1 sin theta equal to n2 sin theta, n1 sin theta 1 is equal to n2 sin theta 2. It also says that refracted ray, incident ray and the normal at the point of incidence, all these three lines or three vectors must lie on same plane. So how do I impose this condition in this problem? I can write a cap dot b cap cross k cap must be 0, because b cap cross k cap is a vector perpendicular to both b cap and k cap, and if a lies in the same plane, then this vector b cap cross k cap and a cap, they must be perpendicular to each other, and dot product of two perpendicular vectors, you would remember, if f1 dot f2, if they are perpendicular to each other, its value is f1 f2 cos alpha, and if alpha is 90 degrees, so it is f1 f2 cos 90 degree, which is equal to 0. So from this I can definitely write a cap dot b cap cross k cap is 0. Alright, so now I should impose this condition, which is nothing but Snell's law in mathematical form. So b cap cross k cap is how much? B cap we have already found. B cap is actually, b cap we have written, we have assumed I alpha plus j beta plus k cap gamma. B cap is I cap alpha plus j cap beta plus k cap gamma. So b cap cross k cap is I cap cross k cap, so is minus j cap alpha, because k cap cross I cap is j cap. So k cap cross I cap is j cap, you know. So I cap cross k cap is minus j alpha, and b cap minus j alpha plus j cross k. J cross k is I cap beta. So I can write like this. Very simple. So I cap cross k, this is I cap cross k is equal to minus j alpha plus j cap cross k is I beta, and k cap cross k is obviously 0. K cap cross k cap is 0 because there it is 1 into sine of 0, which is 0. These all you know from vector analysis knowledge. So b cap cross k I can write minus j alpha plus I beta, and therefore a cap we have already found. A cap is this much. So a cap dot b cap cross k cap is how much? This is beta times 6 root 3 by 20. Is it okay? Because beta 6 root 3 by 20 I cap dot I cap, which is unity, minus j cap alpha dot product with 8 root 3 by 20 j cap. So it is minus alpha 8 root 3 by 20, and there is no k cap term over here, so this term does not contribute in the dot product. So this is equal to 0. That means I can write this 6 root 3 by 20 beta is equal to 8 root 3 by 20 alpha. Therefore beta, so root 3 20 they cancel. So beta equal to, or alpha equal to, you can write 3 by 4 beta. Alpha equal to 3 by 4 beta. Now we know that alpha square plus beta square plus gamma square is equal to unity. That we have already written over there. So alpha square is actually 9 by 16 beta square plus beta square plus gamma we have already found is minus 1 by root 2. So it is plus half is equal to unity. So what we can write? 25 by 16 beta square is equal to half. So beta is how much? Beta is 4 by 5 1 into 1 by root 2. So what we have found? Beta equal to 1 by root 2 times 4 by 5, and therefore alpha is actually 3 by 4 beta. So 1 by root 2 3 by 5, and gamma is already, you know, gamma is minus 1 by root 2. So I can readily write the expression for beta, substituting the values whatever you have opted. So what is that? So alpha is, so I can write b cap is equal to, alpha is 1 by root 2 into 3 by 5 I cap plus beta is 4 by 1 by root 2 if I take out, so 4 by 5 j cap, and gamma is minus 1 by root 2, so it is like this. So it is 1 by 5 root 2 3 I cap, this is k cap, 3 I cap plus 4 j cap minus 5 k cap. So b cap, which is the unit vector along the refracted ray, is 1 by 5 root 2 3 I cap plus 4 j cap minus 5 k cap. So this is the expression for unit vector or value of unit vector along the refracted ray B. So this is the answer, 1 by 5 root 2 3 I cap plus 4 j cap minus 5 k cap, and you can easily verify the magnitude of this vector is 9 plus 16, 25 plus 25 is 15 divided by 25 into 2, 50. So magnitude is actually unity. So it is truly a unit vector, and the unit vector's expression is like this. So this is the problem. I hope you have understood. It is tricky in the sense that here actually you have to apply Snell's law faithfully, Snell's law for refraction, which says that n1 sin theta 1 is equal to n2 sin theta 2, where theta 1 is the angle of incidence and theta 2 is the angle of refraction. That we have done. And another thing, we often keep silent about that part. It says that angle of the incidence, ray of incidence, ray of refraction, and the normal to the plane of incidence, normal to the point, normal at the point of incidence, incident ray, refracted ray, and the normal at the point of incidence, they all lie in the same plane. And that we have expressed mathematically by this expression, a cap dot b cap cross k cap equal to 0. So using that part and this part, n1 sin theta 1 equal to n2 sin theta 2, we could solve the problem. Okay, so it is interesting in that sense that you have fully exploiting the power of Snell's law to derive, to find out the unit vector along the refracted ray. I hope you have understood the problem. I hope it is useful also. So you can just verify, you can solve it, work it out again on your own, and I hope you will be able to solve such type of problems in your exams. Thank you very much. Thank you for your listening.